All right, honors kids, I'm sorry that computer is not wanting to let me write. So we had left off talking about positive ions, and we said that positive ions became positive ions because they lost electrons to obtain noble gas configurations. And we said, by and large, metals did that. And then we started talking about the nonmetals and said that they gained electrons to become positive ions. Or not positive ions, sorry, I misspoke, negative ions. Negative ions are called anions, and anions are like the anode of a battery. Anode is the negative end of the battery, an means negative in Latin, or without. So an anion is a negatively charged ion, and to designate an anion, we add the word "ide" to the root name of an element. Thus, chlorine, the root of chlorine is chlor, so we're going to call it chloride. Fluorine, the root of that is fluor, we're going to call that fluoride. So what would be the anion name of nitrogen? So the root of nitrogen is nitro. So we'd actually nite. So we call it nitride. Okay, so here's the big idea here, the profundity. Nonmetals tend to gain electrons, and they form anions. Okay, so metals lose electrons to form cations. Nonmetals gain electrons to form anions. So nonmetals from group 15 always form +3 or -3 ions. And nonmetals from group 16 always form -2. And nonmetals from group 17 always form -1. Okay? Think about it this way. These guys are missing, the group 15, they're missing 3 electrons for the noble gas configuration. So they're going to gain those 3 electrons. Group 16, they're missing 2 electrons, so they're going to gain those 2 electrons to form that noble gas configuration. And group 17, they're missing 1 electron, so they're going to gain that 1 electron to form that noble gas configuration. So I think we should probably fill this in on our periodic table. What do you think? So first thing first, I am going to get my periodic table back up. And I am going to draw with a thick red line. We're going to make this red, and we're going to make it pretty thick. I'm going to draw the stair step that goes between the metals and the nonmetals so that we can distinguish what's going on there. Okay? So group 15, we said that these guys would acquire a -3 charge. So I'm going to change my color. Now we can really only say that for the nonmetals. So that would be just nitrogen and phosphorus. Remember, arsenic is a metalloid, so it really doesn't qualify as a nonmetal. So let's put this in. Let's make this, we'll make that orange. So these guys are going to be, oh, and that's really thick. I don't want it that thick. These guys are going to be a -3. Okay? And then we said that group 16 would have a -2 charge. So let's color those guys in. Let's get a different color. Let's do those guys in orange. Now, once again, we can't put tellurium in this mix because tellurium is a metalloid. So we can really only concentrate on the nonmetals. So oxygen, sulfur, and selenium will indeed have -2 charges when they bond and make ionic compounds. And last but not least, let's get yet another color here. Let's do this baby blue. The halogens, metastacene is considered a nonmetal. We don't really have metalloids down there. These guys will always acquire a -1 charge when they are bonding with things. So, -1. Okay? Now, the noble gases don't acquire any charge because they don't react with anything. So, we have a fair amount of the periodic table already determined on the charges. Okay? So, let's do some more. All right. Let's look at this. The periodic table shows elements A through G. For each labeled element, state the number of valence electrons and identify the ion that would form. So let's just put in the stair step of the metals to nonmetals right here. Okay, there's the stair step to help you out. This is group 1, 2, 3, and so on. Okay, so let's do A together. So if I'm going to look at A, I'm in group 13, and that's right the spot that aluminum is, right? So if I look at aluminum, I have 1, 2, 3 valence electrons. So I have 3 valence electrons. And so is it going to be easier for me to lose 3 or to gain 5 to get my octet? Remember, we're always trying to get a noble gas configuration. And a noble gas configuration is 8 valence electrons, or an octet. Okay, so I think it's easier to lose 3 than to gain 5. So I'm going to form a +3. And if you paid attention, aluminum always does form a +3. So I want you to go look at B, C, D, and E. Give yourself a minute and come back and we'll check. All right, you guys ready to check? So B is in group 2. So what can we say about group 2? Group 2 has 2 valence electrons, and what did we say about group 2? Group 2 always creates a +2 charge. C is in group 1. It has 1 valence electron, so it's going to form a +1 ion. Okay, D is in group 15. It has 5 valence electrons. So it's a lot easier on 5 valence electrons to gain 3. So it's going to get a 3 negative or -3 charge. E right here is in the halogens. So it has 7 valence electrons. It is a lot easier to gain 1 electron. So it is going to form a -1 charge. F is in the noble gases. So it has 8 valence electrons. It's already totally full. So ion formed? Not really. It's not going to form an ion because it already has a noble gas configuration. And then G right here is in group 16. So it has 6 valence electrons. That means it just needs 2 more to get a noble gas configuration. So it will create a -2 charge. All right, so let's see how this works when we create ionic compounds. All right. All right. So ionic bonds form as the result of the transfer of electrons. So I'm taking the valence electrons of the metal atom and I'm giving them to the nonmetal atom during a chemical reaction. So the metal becomes a positive ion and the nonmetal becomes a negative ion And the attraction between the positive and the negative is what holds that molecule in place. Okay? It's kind of like dealing with little magnets. All right? So the electrostatic force that holds the two ions together due to their different charges is what makes the ionic bond. Okay? Ionic compounds have the following properties. They tend to form crystals. So we will get crystalline shapes. This is an electron micrograph of sodium chloride, otherwise known as table salt. If you have ever looked at the salt that you pour out of the salt shaker, have you noticed that the salt comes in tiny little cubes? So the chloride ion are these large ones on the ends, and the sodium ions are these little tiny ones in the middle. Okay? Notice that we have a perfect cube going on here. This type of arrangement between the positive and negative ions here is what we call a face-centered cubic arrangement. Okay, because on the face, we have a center on each face. So that's what we call it, a face-centered arrangement. Now, when we get to AP chemistry, you will learn the different crystalline arrangements and how they interact. Okay? Ionic compounds have high melting points and high boiling points. Now, just to give you an example of how high melting points and boiling points are on ionic compounds, if I threw a handful of salt into a frying pan on the stove and I tried to melt it, the pan would melt first. The stove would probably melt first too. And to get salt to boil, oh boy, you're talking a couple thousand degrees. It's super, super hot. Ionic compounds also tend to dissolve pretty easily in water, and they create electrolytes. Maybe it has something to do with electricity. It sure does. So an electrolyte is a substance that, when dissolved, so when it's dissolved in water, it will conduct electricity. Okay? How many of you guys have seen this word electrolyte or electrolytes on the side of like Powerade or Gatorade? Yeah. So they have ionic compounds dissolved in Gatorade or Powerade because guess what? Our nerves conduct electricity, and that's how neuro signals go back and forth between our nerves and our muscles. And when we sweat out a lot of salt. And we need to replace that salt for our nerves to conduct pretty well. But honestly, for the most part, unless you're working out for more than 90 minutes, you don't really need electrolytes. Just water is good. Okay? Ionic compounds are hard, rigid, and they are brittle. Brittle just means that if you hit them, they shatter. So if I hit a crystal with a hammer, it will shatter. It doesn't bend or move. Because ions in the solid state are not free to move around, they will not conduct electricity. To be able to conduct electricity, ions or charged particles need to be able to move. However, when these ionic compounds are melted and in the liquid state, those ions are free to move around and they will conduct electricity. Okay? In a later chapter, we're going to spend a lot more time naming and writing formulas for ionic compounds. But for this lesson, it's important that you know that ionic compounds are formed by the transfer of electrons from a metal or a positive atom to a nonmetal or a negative atom during a chemical reaction. Okay, so have a great day. We'll practice these a little bit in our homework and have a great time. We'll talk to you later. Bye.